Last video in our little follow along brick breaker series. Again, all the code on this will be up on the website. So in the last video, we made a game manager that's going to track the game state with a little state thing, a little game state variable, an enum. And then we did a little bit of that was the main thing we did. But I did a little bit of extra work that you may or may not have done yourself by having the bricks spawned in automatically instead of having to drag them in myself, which for a brick breaker game, probably not that big of a deal. I could drag these in myself. You might want different levels. I might want a lot of authorial control over them. But I did it anyway because it was fun. And I'm lazy. Maybe I spawn it in and then I copy the bricks and I paste them in the scene and I delete the spawner and I call that a day. So the whole point of this video series is to bring us from the point where we are prototyping and hacking into making like an actual thing that's a playable game. And we're not quite there yet. While we have a game over and game victory and game lose states, I am not communicating that to the player at all. So we need to figure that out. Part 2, I can't restart or replay after I've finished. So I need some kind of level manager thing that can restart my game. And then after that is just going to get into little strategies for doing polish and for doing juice and little other tricks and tips. We'll see how long this video goes. I'll sort of, I'll leave all that stuff to the end because we can kind of just skip it, or you can, infinitely deep topic to dive into. And as a learning objective, it's not as core to this my video here. So the you win and you lose states. The first step, I guess, is to design them. And we're going to use a good old-fashioned UI canvas to do that. So I'm going to create a UI. I'm going to create a canvas. Canvases are, and you can say also made an event system automatically. Canvases are in their own space, their own coordinate system, where one number no longer represents one unit in the world, but one unit in the canvas is like, maybe it's like a pixel or pixels per unit, 100 right here. Okay, so it's about 100 pixels. But that's much larger. So my canvas space, which I can see if I zoom out all the way, this big square is, it's so much bigger than my gameplay space. So seeing them on top of each other where they share a 0 position, often that's very annoying. So we'll note that Unity has helpfully provided a UI layer here, and we can go to our layers tag and we can hide that so we don't see it in the scene view, or we could just in the hierarchy hide layers, or click this little selection box so I don't accidentally click on my layers. Anyway, we're going to make a parent object for the you win state and a parent object for the you lose state, and we're going to just enable and disable those states. And below those states will be all of the text and buttons and everything else that might get turned on and off in the UI. So let's make that. We'll create an empty, and I'll call it HUD for heads up display if we want lives to appear on the screen. I forgot about that. That's another thing I want to do. And then we'll make another one for victory, and then Control D, duplicate another one for game over. All 3 of these, we want to make the same changes to their rect transform. I want them to just be full screen panels. So my alignment here, I want to be this bottom right one stretched to all the different edges. And I want to be 0 pixels away from all the different edges. Great, let's start with victory. Let's ignore the HUD. Let's add a UI text. We want to use TextMesh Pro because it's 2022. So that means I have to import the TextMesh Pro Essentials assets to get some fonts and some stuff to use with that. Okay, great, go away. But now I have text on my screen. And this is going to be victory, you win, exclamation point. But let's make it, bigger. And let's make it bigger, fine. Font size 120, I don't know, whatever. Let's align it centered. So if we make it too big or too, it doesn't really matter. If we make its width larger, as long as it's large enough to hold the text, then we'll be fine there. And then let me rename that you win text. And let's duplicate it, Control D, drag it into the game over UI, and call that you lose text. And of course, we'll want to rename it. So now on our canvas, my game will have these disabled, and when I win, we'll display the you win text, and when I lose, we'll display the game over text. But it's usually convenient to have them either all enabled or all disabled, and then I can turn this off while I'm checking that, and I can turn this one off when I'm checking that. So I want the game to sort of configure itself on awake and like turn them off and on as needed. So on my canvas object, I'm going to write a little canvas manager. And this is going to turn on and off the various children objects that it owns while paying attention to the game manager's state. So we're going to make a new script, and we're going to call it UI manager. And I'll attach that UI manager. At this point, I think I want to make a subfolder for any UI scripts I have. I might only have this one, but it's like I can't not bring myself to do that. I like to prefix my UI scripts with the word UI. I like to put them in a UI folder because they tend to have very similar names to other things for the UI element of those other things. So anyway, now we can open up our UI manager script. Great. So we're going to need a public game object for victory, a public game object for game over, and a public game object for the HUD panel. Yeah, so now we just need to use the .setActive functions to turn them on and off as needed. So we'll start just by doing a basic version, victory panel, .setActive false, lose panel false, and then HUD panel true, because I want the HUD to be on when the game runs. On game over, I'll do the same thing, but I'll change this to true and these to false, and then set game over panels, set victory panel. Let's name our functions a little bit more descriptive of what we're doing. And then victory panels will turn victory on and the other ones off. Yeah, great. All right, let's just see if it does it on awake. In our canvas, our panels here, victory is this one, lose is this one, and HUD is that one. And let's just see that when I hit play, the you win text should not be on screen. Great. So now I need the UI manager and the game manager to talk to each other. So the question is, how do we deal with that dependency? And this is not an insignificant question. Do we want the game manager to tell the UI manager that it exists, or do we want the UI manager to look for the game manager and check its state? And the direction that this dependency goes is sort of going to control how our game works. And so what we want to think about is sort of how is this game structured from a sort of a top-down level. So we have our manager, and currently we have our ball, which talks to the manager. It tells the manager, hey, I'm off the edge of the screen. We have our brick, which does the same thing. It talks to the brick. And then we have the UI. And then we're trying to figure out if we want this to look at the manager or if we want the manager to call those win and lose functions on the UI. The reason I'm drawing those as arrows is because it's sort of going to introduce how our problem is working. If I have the manager call the function on the UI, then what I've introduced is this sort of dependency that in order for the ball to work, we need a manager, which I guess makes sense, but we also need the UI in the scene. If I delete this UI canvas, my game will break for the ball. that doesn't feel right to me. Because the ball will call the manager function. The manager will try to update the state on the UI. So that's bad. We don't want that. So we want to minimize, like that's a dependency that I don't want. I want to minimize those kinds of dependencies. So I like, I like having everything talking to the manager because, listen, I need the manager anyway. Like if I'm already going to be stuck with this thing that all of these things are dependent on, we want to reduce these dependencies as much as we can. If I'm already going to have it, we might as well keep that same pattern. So we're not introducing these sort of chains of dependency where, okay, I put the player prefab in this scene. Great, but the player prefab needs a player manager. Okay, and the player manager needs a UI. Okay, and the UI needs a score counter, and the score counter needs a sprite lookup table and a lookup, and you have all of these, like, it makes it very hard to test your game in isolation or make small scenes or make testing scenes if you need suddenly all this other stuff in order for the game to even function. And that can happen with those sort of dependency chains. This needs that, and that needs that, and that needs that. So we want to minimize that. So we're going to have, I want my game state to look at the game manager. So that's how the logic is done. So in my UI manager, we'll have a public game manager, and we'll call it game manager. We'll call it the same name, but I named the variables in the other scripts. I should be consistent about that. I don't think I am being. And then we need to check. Now, the easiest way to do it would be to just in update, look at that code every single frame and check if it's changed. So we're just going to do that. There's a code smell here, which is checking things in update. That feels dangerous. That feels silly. But like, it's going to be fine. We'll introduce a strategy for dealing with that in the future with an event system. But we don't have event systems. What we do need to get is this game state, which is in fact public. I said I would make that private. So I'm going to make that private. And I want to introduce so I want to be able to read it from somewhere else, but not change it from somewhere else. So a private getter, private setter, but a public getter. I need to be able to get the game state. And we can just write a function that will do that. Something that is public, that will give me the game state, but I don't have access to the internals. My UI can't accidentally update the game state. It is harder for me to write bugs now. So update if game manager.get game state is equal to victory. Then we will set victory panels. Else we will set game over panels. Whoops, no, that's not right. Else if. Sorry, well, it was about to say game over on. It was about to say game over on during gameplay. Else gameplay. And we'll just probably should actually do a set gameplay thing, but it's fine for now because we don't have set gameplay panels. This will keep running all the time. This will keep running constantly. It will check itself over and over again. But that's fine for now. But if we were playing a sound, then we only would want it to be true for the first frame that like it is the victory state. And again, the correct solution, I believe, is probably to use an event system, and that's not what we're doing in the scope of this video. So I'm not going to introduce sort of a half measure example on how to fix that. If something we're enabling a game object, we can just keep enabling that every frame. It'll stay enabled. So we're going to get a null reference exception. Whoops. My canvas is dependent on my game manager. Got to drag that into that slot. But there we go. That's a very informative, easy to read error message, easy to fix. Both of these things will exist in my scene. Great. Amazing. So now we just need I want a button or something where I can restart the game and play it again. So let's do the button first. We'll do it on the game over scene. And we'll make a little UI button. And I'll drag that down and I'll make it bigger. not that big. We'll call it restart game. No. Sure. Restart game. And then I need to probably make that a prefab restart game button. Let's go to my prefabs because we want this in both of my game over and in my victory states. We want the same button to appear. So I definitely want to use a prefab here. Making a prefab, making a little UI folder in my prefabs. And I'll call that there. Then I'll put that there. No, where am I? In the victory thing. So now my game over as a restart game button and my victory as a restart game button. And I can update the prefab and those will update. Love a prefab. But now we just need to have that restart the game. Well, time for another manager. The game manager is managing the game. I don't want it to deal with our game. Instead, we're gonna do a scene controller, scene manager. Scene manager is a name that's already taken by Unity doing other stuff. So without getting into namespaces, we'll call it something else. And I'm gonna call mine scene controller. Even though in my head, I'm like, it's just a scene management. And this scene manager, we're gonna write our optimistically named function. We're gonna write a function that does what we want it to do as far as the other systems in our game are concerned. So before I even know how to restart the level, I just know that my button needs to call a function. So let's make a restart game function. And restarting the game, as it turns, is actually fairly easy. We're going to use something in the scene manager. To use it, we'll need to go up to our using statements. And we'll need to add, I used a autocomplete here that added it for me. We're going to need to add using Unity Engine .scene management up in our using statements. And then we'll have access to scene manager. And to reload the scene, we just need to call the load scene function and give it the current scene, which we can get at getActiveScene dot name or dot build index. We'll do build index. So we take the current build index of the currently playing scene, and I tell us to load that scene, and that will unload the current scene and then load the same scene, which will effectively reload the scene. So now I have a little public void restart game. And now my UI button can call that function. So to do that, let's take our scene controller, and I'm going to just add it to my game manager object because it's managers. It's another manager, but it can just live on that one object. That makes perfect sense to me. Yeah. Managers. Sure. We'll go to our button. On click, I need to add a function for my head is blocking you. Hello. Okay. I need to add a function on the click of this button. And I'll need to go to my managers and drag it into that slot. And then choose my scene controller. And we have to make it public so it'll appear in this list. But if we do, we can restart the game. If I try to, I want to apply this to the prefab, huh? I want to override, I want to apply that to the prefab. But it doesn't work because that manager is a reference to the scene object. So I will, in this case, need to go and do that again for the other restart button. There you go, restart game. See other videos and example projects I've made which have bypassed that issue by having a scriptable object scene controller. Something that exists outside of scenes that can load and unload scenes. That makes sense to me. So let's just die real quick. And then I should be able to click this button and it should reload the scene. Nice. Oh, wow. I hit that gap and that was oddly perfect. And looks like my random value is straight up and down. And this is what a great segue into the thing that I was planning on covering next, which is to add a little friction, add a little kick to the ball. So if I'm moving left, I can control it. So to do that, I'm so happy that just happened. Let's hide our UI and let's grab our paddle and tap the F button. Beep, zoom in on that. And we're going to make this paddle a prefab as well, because it's just going to make life easy for us to work with. Square. I'm going to rename that depth zone. Okay. Sorry, I just didn't. I don't like unnamed objects in my scene. So my paddle, and we can go into the prefab and we can adjust and edit it as we like. Oh god, I want to get rid of these comments. I don't need these comments anymore either, but we'll get to that. So my box collider, be gone. Get out of here. Remove the box collider. Instead, we're going to replace it with the polygon collider 2D. And the polygon collider is by default going to wrap around whatever sprite we have, which is that square. Time to edit it. So I click on edit. And I'm going to add a little dot right here, a little dot over here. I'll grab the corner. I'm going to pull that in. Pull that down. It's hard to make it symmetric. There's other strategies. You can make the paddle in 2 halves using like child prefabs that are clones. And you could set the scale of 1 to be -1, and then they'll be exactly opposite. In our case, I just want to put one right in the middle. Matching, not quite. And this one's teeny little bit up, teeny little bit of an angle. There we go. Haha. So I've my paddle, which will still look square, now has this collision shape to it. Again, so one way to do that custom collision shape that's symmetrical is to make 2 as a children and flip it. Another way to do it is this will automatically try to wrap around a sprite. So if we make a sprite that just is that paddle shape and then add a polygon collider to it. And then the last way is we can do math and make sure, whoops, my face is blocking again. We can do math and like just make sure these things find the 2 points that we want to make sure of the same height and just set their values in the array here. But that's time consuming and I'm in a video, so you can deal with that. So now if I move into the side, that little bit of angle should like, ooh, yeah, you see that kick to the side? Didn't quite work. Next bug is that the paddle feels really floaty. Next bug is getting rid of this debug.log statement I don't need. Okay, the next bug is that the paddle feels really floaty. I move left and right, and I let go of the mouse, the keyboard key, and I still slide a little bit. And it's doing that because of gravity. It's simulating the joystick that is moving to the side and then taking time to snap and whoop. Hunter from the future here, revising this part of the video because my recording got messed up. So to change the way that a input axis snaps and is affected, we can go to our edit project settings. In project settings, we can go to the input manager. And then here we have our different axes, which is the actual string that you'll type in input.get axis, right? Horizontal, we can see here, left and right on the keyboard. There are these other settings here, gravity, dead zone, sensitivity, snapping, things like that. Sensitivity, the speed to move towards the target value. Gravity is the how quickly it falls towards neutral or towards 0 when you're not inputting anything. And so on. So we could make these very high, but there's the other solution, the one that I'm going to use or did use in the video, which is instead of using get axis, we would use the get axis raw function. And the get axis raw function just skips all of those smoothing, filtering functions. So if you have left on the arrow key, it's -1. If you let go, 0 instantly. So that's the one that I'm recommending. We use for doing keyboard input into axes to make it feel nice and snappy. Okay, back to the video. Here's another problem. See, there's an issue here. See if you can identify it. The next issue with our game is that the player and you may have noticed this. The player is real jittery when it hits the wall. And if you start Googling or searching or trying to figure out what the cause of this issue is, what you're going to discover is that the solutions out there are going to tell you to use move position instead of using it yourself. And the solutions are going to tell you to turn on interpolation for the paddle. So we can do that. We can set our interpolate mode to interpolate. But that's not going to fix it for it. We're already using move position. We're already doing things the correct way. So why is it not working? And the answer is a fun bug. There is no bug. We're bouncy, and the walls are bouncy. So to resolve this problem, we can go to our walls, and we can take the bouncy material right out of there. It was a mistake by me to add that in the first place, because I don't want everything to bounce off of those walls. Now, question, will this affect the ball? So there we go. There goes our jitteriness, which wasn't jittery, it was bounciness. The answer appears to be no. So the ball isn't affected because the ball is still bouncy. It has full bounciness. It doesn't matter what the bounciness of the other thing is. It's going to be bouncy. Next, I think, is the camera for me. That's what I don't like. Not specifically the background. Let's go to our main camera. Let's take our background and set that to be solid black. And let's fix these boundaries. So for us, the solution is going to be just to ballpark it by lining it up as best we can with the preview in the inspector. And then I got 9.39 and negative 9.39, and that makes sense. Let's make those should be the same on opposite sides. So anyway, we could do the math and figure out exactly where these things need to be, but the easy solution is just to eyeball it instead of having to take a square root. Or am I going to pull out a calculator? Well, who is the time? Oh, now we're looking like Breakout. Oh, that was weird. I can't really read the game over text behind the screen. We could probably just make that smaller. Let's lock our input so we can't move during game over or during victory. Because I can keep moving. So let's do that by giving the paddle a reference to the game manager, and then we can only move if we are in the gameplay state. And then in update, or I guess, yeah, just wherever we're actually moving it, if game manager dot gets game state is equal to gameplay, then we will do that movement. So we'll just wrap up our movement code behind this check that we can currently play. And now we're starting to see a pattern where we're getting a reference to this game manager all over the place. And that's getting a little smelly. That's smelling like some potential bugs are going to happen. Oh my gosh. We'll make this text smaller so I can see what's going on, and I can lower it down a little bigger. Something like that. Okay, what's next? I believe I want the ball to not fire immediately. I want it to stay still for a second or two before it launches. So to do that, we're going to use a pretty classic pattern. We're going to use a little update timer. So we're going to make a private float, call it timer, and I'll make a public, put it up by this other variable. Whoops, hold on. What's just happened? I'm all over the place. I'll make a public float, and I'll call this one delay before launch time. In update, I will increase this by the amount of time that has passed in seconds since the previous update frame, which will increase this variable at a unit of 1 unit per second, and thus it is a timer. And then if timer is greater than delay before launch time, then I will greater than or equal to. Hypothetically, that might happen, but we definitely need the greater than, because it's going to be moving up by sort of, it's going to be jumping up each frame by small amounts. Unlikely to actually be exactly a certain value. Then we will fire in random direction. And here in start, instead of firing in random direction, I will set my timer equal to 0. There's going to be a bug. And that bug is going to be that this will keep happening in update over and over and over again, which we don't want. So let's make a private bool, and we'll call it launched. And we'll set it to false in start to be sure that we have not launched. And then if we have not launched, then I'll do all this stuff. Otherwise, and then in my fire in random direction code, I will set launched equal to true. Yes, I have launched. So now it'll only increase the timer and only do these checks, and it'll only call that function if we have not launched. That way I don't have the random number just getting bigger for no reason. Maybe I do want that. Maybe the ball should slowly speed up over time or do something else. But for now, a single Boolean check is not inefficient. We can do that in update pretty much as much as we please without a problem. So in our ball prefab, let's take that delay time, set that to a second. I'm gonna lower the launch speed. It seems like it's going a little fast. Right. We're basically done. Like I mentioned before, whoops. I forgot to give my paddle a reference to the game manager. Okay. Great. Again, an easy bug to find and fix. The error tells me exactly what the problem was. I just have to remember to read the errors. So when it dies, it hangs out there for a second. So there's an interesting question is, what happens if another ball hits it? And the answer to that question is they'll both bounce off of each other. It's not locked into place or anything. And I think that's fine. I kind of like it. We could set the constraints to lock its position and rotation until we launch, and then we could unconstrain it. We could make the kinematic and then make it dynamic on launch. But I think it's pretty good. I that's such a rare possibility, and if it happens, it's funny. And I enjoy that. I think that makes me happy. So I want my game to have those fun little emergent moments of, hi, Future Hunter here again. The video's over. It's done. We have done it. We have explored using game managers and how charting dependencies on a graph and figuring out where they go. We've explored a simple state machine to keep track of that other objects can sort of pay attention to and functions can look at in if statements. And we've even explored taking a game manager and trying to split it up as much as possible. For example, in the ball script, we were able to add that delay before the ball launched very easily because the original ball was we put that logic in its own script and not in the game manager. We kept things nice and separated, which made adding these little bits of features and adding little things much easier. So the rest of this video here, as I edit it, I'm I'll just delete that. Nah, I'm going to leave it. The rest of this video is I changed the colors of the bricks automatically, but we're going to cut that out because it wasn't very educational. It was kind of muddly. And then at the end, I make a little HUD of lives being displayed. So that's all going to come up at the end, but consider that extra. So cool. Hope this was helpful. We'll make a HUD. We'll do it fast. Consider this video over. Go away. We're done. I'm not doing any work right now. We've all made Breakout. And it's pretty great. And there's no more work. There's no more things to be doing. And that's it. I feel like I'm lives. What are you doing? All right. There's nothing going on. I don't know why you're still here. Why are you watching? Why are you watching? Why are you watching me create an object as a child of myself? Create lives number of these objects as children of myself after first destroying all my previous children. Destroy my children, create that number of children. That's not going to arrange them left to right. Or will it? If we go back to Unity and we add a child object to the HUD, call it lives display, and we'll put this in the bottom left. And as a child of this object, we'll make a UI image and we'll have a circle. All right, I need circles, assets, game data, create 2D sprite circle. Sure. And it's gonna be nice and small. No, bottom left. And you're gonna be a little bit off of the edge. Totally bottom left. Height 20 width. Some other number. Then you want to be bigger. 20 by 20. There you go. There you go. And anyway, so the big trick is in our lives display to add a horizontal layout group that's going to control their position for us. We need to middle left. Screen. And now if I have multiple children, they will display. So we'll put a little bit of spacing in there. Yeah, great. So then if this, if we make a prefab for our life icon, can give that here, destroy all of you, and then this lives display will add the right number of children, and then the layout group will display them in a row, and now we just need you to talk to the game manager. And update. We don't know how to get the already have update. We need to get the lives. So just like we did with getting the game state, we'll have get lives return lives. So a public function where we can get access to a private variable called a getter. And now we're UI lives display. If display lives is not equal to game manager dot lives. Oh, total lives was public. Oh no, total lives was public, but current lives was not. I think I'm doing this check twice. So we could probably just do that. To do event system. All right, the clear next step for this project is an event system. And that might be worth doing, but that's not the initial scope. Let's see, does it work? Don't have the game manager assigned. Does it work? It's beautiful. It's a beautiful thing we've made. If you've made, if you have the, yeah, all right, so we're done. What I realized about doing the color for the brick spawner or for the set color thing here is that either you did the brick spawner and you have this code, so you have an integer that exactly represents what height we want it to be at, which is very useful, or you did it manually, in which case you have an even easier time. You just can select a row and then change the color. So I'm no longer worrying about about that. And we are done. We are done. We're well past done. We've been done for 20 minutes. I want to show you all of the fun things. But that's Brick Breaker. We made Brick Breaker. Again, this third part of the video is really just like to be a completionist because I'm tired of videos that don't actually tell you how to make games that are just like prototypes. So first we made a prototype, then we made a game, then I did a bunch of other stuff to make it not bad. And here we are. So I hope you enjoyed. I hope you found it helpful.